Well, hey everybody, welcome back to Tech Talk Education. Dr. Heldman here. In this movie, I would just want to differentiate between a couple of different data types. We've had 32-bit versions of operating systems and then 64-bit. Of course, prior to that, we had 8-bit and 16-bit. But data types can come in a range of lengths and widths and capabilities. In other words, how much data they can store and the precision with which they can calculate. And so there's a 32-bit and a 64-bit version. And I wanted to differentiate between those because PowerShell has the ability to differentiate between those. So let's get started. This is going to be a little bit shorter movie, but it's an informational one that just helps you understand the data types that are being used inside PowerShell. So here I am in PowerShell, and we're still talking about variables, but we're talking about the data types that can go into variables. And so let's say that I want to declare a variable that is an integer, so I can just type in my int, for example, and I can initialize it to this, like say 1, 2, 3, 4, 5, for example. Okay, boom. Now if I want to print out my int, I just type the variable name in and I can print it out. By the way, you can type in the getValue method to understand what the value is for, getType method to understand what the data type is that you're dealing with it. So you can say myInt dot, this is called a dot operator. We're using dot notation here, very common in all of the languages. And we're going to tell us that we want to know the get type, like so. I need an E on the end of that. What you're doing is you're invoking a method called getType that belongs to the PowerShell library of methods. And you're saying, hey, I don't know what the data type is here. Can you tell me what it is? And it will yield to you that by default it's an int 32 right here. So this is a 32-bit integer. Now, what would happen if you wanted to, say, cast this thing as a 64? Well, what you can say is you can say myInt is going to be equal to, and I'm going to cast this. Now, casting in PowerShell is a little bit different than in other languages. In another language, you might have in parentheses float, and then whatever it was you wanted to cast. But in this case, like, let me see if I can show you an example. You would say float, and then myInt like this. This is just an example. And so you would use a float method to change everything into a float. Now in this case, what we're doing is we're casting this as a float. We type in the word capital float. Does not need to be proper case. We can put in a lowercase. Not float, int64. int64. We'll get to floats in just a minute. And then, so let's see if this will take this, int64. I might say it's something like this. So my int64 is going to be equal to int64 myInt, because we know that's a 32-bit integer. So let's cast this as a 64-bit. Now hit the up arrow here, and I'll say myInt64.getType. 75 isn't going to work very well, is it? So we do that, boom, there it is, and it says, well, it's an int64. So that's a good thing. Now, what does 64-bit and 32-bit mean? Well, it means that if we have a number that is capable of a lot more precision, then we can use a different number. So there are two types in that Microsoft likes to use, and you'll run into this a lot with other languages as well. The shorter one, the one that can hold less data, the smaller amount, is called a float. And it's a floating decimal, which means that the decimals float as you do math operations on those decimals. So if you take 0.25 times 0.25, you're going to get a 4 decimal long outcome because of the law of multiplying two decimals together. So float is shorter, and so it doesn't have the ability to get as much, what's the word that I'm looking for? precision is the word that I'm looking for. You get a lot more precision with a double than a float. And Microsoft defaults to, at least my experience has been that it defaults to a double these days. Like if you're in Visual Studio and you declare a variable that's going to be, a floating decimal type variable, it's going to opt for the double data type rather than the float data type. I should also point out to you that there is a thing called a long, and I'll clear the screen here. So if I print out my int, this is the 32-bit int here, and then if I say, well, I want to cast this as an int 64, I don't have to use the int64 keyword. I can hit my up arrow here, right there, and instead of saying int64, you can tell it that it's a long data type, like that, and then you tell it to show me my int64. Let's see what it says here. It says, well, I'm in int64. So very good. So you can use long or int64. By default, when you declare an integer in PowerShell, it's a 32-bit integer. So let's try some other cleverness here too to see if we can figure out how this works. So I'm going to say that I've got a double number here. Now we know that a double is a 64-bit floating integer type data type, and we're going to declare a double number, and we're going to set it equal to, and I'm going to tell it that I want to cast it as a double. Now I'm doing something weird here, and this is some syntax we're just going to have to get used to. So this part is the variable here, double number. Next we're telling it that we want to cast it as a double, and I'm going to put in two things, double colon, 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 like this. And I want to set it to its max value. So this is an operator that's saying, hey, I've got this number here, and I want to set this number to a double, but I want to put the maximum value inside this double number. So I hit enter. Now there's one way that you can print out, you can just say, type in double number, and it will spit out that number for you. And this is scientific notation. So this is 1.797, blah, blah, blah. And you can see that this is, 15 decimals of accuracy, and this number is followed by 308 zeros. So it can get really, really big. So that's one way of printing this thing out. We can also use a commandlet called write output, and we just tell it to write out double number, like so. Now write output, we remember that the commandments operate on a verb object, verb noun. So we're going to write, this is the verb, and we're going to write whatever's inside the output that we have, right to the output buffer, I guess is the way you would phrase it, or the output stream, what the what double number contains. And it outputs the same thing. I'm just showing you that you can have it show you what's inside double number by just typing in $ double number, which just shows up in this weird color. Is that like a gold color, I guess? Or you can do write output, which is a PowerShell commandlet, and tell it to write out that variable. Either way works just fine. So that is a double. Now the double's range goes from approximately plus or minus 5.0 times 10 to the minus 324th to plus or minus 1.7 times 10 to the 308th. So there's a lot more negative numbers than there are, there's a lot more positive numbers than there are negative. But the main takeaway here is that you do have negative numbers that can be used inside a double. And there is this concept of telling it that I don't want to do any negative numbers. I want to have everything go to a positive value. So that's something you might want to consider. If you were writing a script and you knew that a number didn't have any potential for ever being negative, you could force PowerShell to display only positive numbers. So then if we have a float, it goes from plus or minus 1.5 times 10 to the minus 45th, which is a much smaller number, even though 45 zeros is a lot of accuracy, times 10 to 3.4 times 10 to the positive 38th. So let's look at this. So let's type in a float number here. I'll do a float number, and I'm going to set this equal to float. I'm just going to cast this guy as a float, colon, colon, max value. Hit enter, and then I'll just call for float number, and let's see what it contains. So it's 3.402823, and you can see that there's only 6 decimals of accuracy in a float compared to 15 decimals of accuracy in a double. So I think the theory is, I could be wrong, but I think a bunch of engineers were sitting around one day and said, hey, you know, all these computers now have so much RAM in them, why do we even care about float? Let's just go ahead and declare everything as a double. So by default, if you declare a floating point integer, like in Visual Studio, it's going to wind up being a double, and maybe you don't want that or even need that kind of precision. Then you want to think about a float. But it is possible to make these be a float. So let's go ahead and let's do write output float number, $ float number, and he's using camel case here for this example. And there we get the same exact thing here. Now I will put the plus or minus here so that you understand how that works. What I'm trying to say is how negative a number can go given a double or given a float, or how high it can go positively. I'll put those up on the screen so that you have that available to you. In a nutshell, the double is more precise because it uses 64 bits compared to the float 32 bits. The double can store larger numbers because of that, and smaller decimals with greater accuracy. Float takes up less memory. It only uses 32 bits of memory, whereas a double uses 64 bits of memory, and a double can represent both larger and smaller numbers than float. So that's the reason why we would use a double as opposed to a float. Now there is an anomaly that you should be aware of, and let me show this to you how this would work. So let's declare a basic number. And I'm just going to put some gobbledygook in here. So I'm going to say that it's going to be equal to 0 dot. As soon as we type in that 0 dot, we know that PowerShell is going to put this thing in there as a double. So we've got 64-bit number that's in there. And let's just pop in some stuff. So 3, 4, 5, 7, 8, 9, 1, 2, 3, 7, 8, 6, like so. So we've got that. And we hit enter. And let's go ahead and display that. So I'll say number.getType. And again, you don't need to do the proper stuff, .name. And let's hit enter. And it says, oh, I am a double, just exactly as we would expect. It's a double data type. We call this the data type. It can hold a double. Now suppose that we wanted to add these things together. So if we said number plus number, like this. And in a double, we're going to get this output here. Okay? But now what happens if we cast this thing as a float? So if we say float $number plus float $number, now we get a little bit different output here. And so that's the concept here. There is a difference in the precision based upon whether it's a 32-bit float or a 64-bit float. There is a difference in these 32-bit float versus a 64-bit double. There is a difference, a little bit of a difference in the way that this is calculated, and you might be concerned about, okay, am I getting the correct information? I want you to make sure that you're aware of this, so when you're casting something as a float down from a double, maybe you get some weirdness in the output of a calculation. I don't know. It's just something to be aware of, and maybe do a little bit more investigating on your own. Okay, thank you for listening. Hope this helps you, and you have a great day. Talk to you sooner.